Hello and welcome to How Globe Telecom Does Primary Backups via StorReduce to AWS. My name is Isaiah Weiner. I'm a Senior Manager of Solutions Architecture for AWS in the partner organization, and I'll be your host and moderator for today's webinar. In addition to my introductory presentation on AWS Backup and Recovery, we're going to hear today from Hugh Emerson, CTO of StorReduce, and Dandelo Cardona, the Infrastructure Architect at Globe Telecom. When we talk with customers at AWS, a lot of customers tell us the challenges that they have with storage on premises, and there's lots of categorizations of storage. Of course, there's everything from primary storage to backup and recovery, archive, and even solutions related to BCDR. What our customers generally tell us is that when they address the challenges on-prem, they're trying to address issues around logistical complexity, capital expenditure requirements, the difficulty of audit and regulatory compliance verification, and then lastly, just the actual cost components. The way that we try to meet those challenges is through the building blocks of AWS. The way that we try to address those challenges through the building blocks of AWS services largely have to do with taking advantage of things that are managed. And what that means is that customers seek to relocate those workloads in a way that gives them less infrastructure to worry about, and they seek to fill the gap between where those building block services end and where the requirements begin with third-party solutions. So that is an opportunity for the AWS partner ecosystem to come in and fill the requirements gap. What our customers tell us is that by using AWS technology partner solutions like StorReduce, they enjoy the fact that their existing workloads, oftentimes the workflow itself doesn't have to change that much. Sometimes it doesn't have to change at all. And in the process of performing the integration, not only are they gaining efficiencies where it pertains to cost because there's no capital expenditure, but they're also having to only pay for what they use. That utility pricing model is something that extends not only to things like AWS EC2 and S3, but for our partners that embrace this similar licensing model and who can be procured through the AWS marketplace, that utility computing procurement model extends to their solutions as well. So especially in the case of where customers maybe wouldn't have an opportunity to or wouldn't have an ability to perform some kind of large CapEx on traditional legacy applications or traditional legacy solutions, the ability to actually do it on an hourly basis through AWS Marketplace is something that's new, and it not only adds to the cost efficiency, but it adds just to the logistical simplicity. In addition to the logistical simplicity, our customers tell us that using things that can be deployed in a scale-out manner and adopting the cattle approach in the pets versus cattle analogy of legacy IT workloads being pets and things in the cloud being a little bit more cattle-like, not having to pay so much attention to the individual properties of each component, but worry rather, what's my business outcome? They can do that with AWS. And then lastly, on the security component, the ability to have repeatable and auditable environments that you can turn up, in a one-click fashion through things like CloudFormation templates and automated quick starts and AWS Marketplace automation means that not only are the initial bring-ups secure, but they're also repeatably secure, and that's really what lends itself to the auditability. So the APN, or Amazon Partner Network, strives to really highlight the best of breed when it comes to AWS technology partner solutions and our managed services. There's a lot of components to our services. We have over 90 services. It's even hard to keep track of them. We jokingly refer to it sometimes as the periodic table of services because, just a short while ago, there really weren't that many services out there, but now, with that number very quickly approaching 100, it's confusing sometimes and difficult to understand where a customer should integrate. Some things are very easy and intuitive. S3 is the Swiss Army knife of storage. IAM, for example, you know you're going to have something to do with identity management there. But then there's a whole lot of things that people just maybe don't understand or see how they can integrate with easily. So if you're a startup, or if you're very much on the cutting edge of technology, if you're developing an application, there's a lot of things that you might take advantage of that simply aren't applicable in a traditional IT workload. For example, if it's an application you don't control, how would you integrate it with something like KMS or SQS? And that's where the APN Technology Partners come in, because they've done the work for you. And they get to take advantage of all of these amazing developer tools, but then present to our customers top to bottom a complete solution. So those building blocks that I referred to, a lot of folks know about S3 because it was our first service. It's an object storage platform. I won't go into what distinguishes object semantics from others, but I will make analogies. So for example, EBS, our Elastic Block Store, that's a block interface. Other examples of block interfaces are the hard drive in your computer or the flash in your phone. If you have an iSCSI appliance in your office, that's another example of a block interface. A fiber channel network, SAN, those are all block interfaces. So people know about EC2, they know about EBS often as their boot device. Less well known are other services like Amazon EFS, which presents a managed way to do file interface using the NFS protocol. Those use cases of legacy IT workloads that are file-based often take advantage of things like EFS, but they can also take advantage of things like EBS with a file system on top of them. When we talk about hybrid workflows, EBS is something that can only be used in the cloud, so hybrid workflows don't take advantage of that. And for that reason, a lot of our technology partners are orbiting things like Amazon S3 and Amazon Glacier. The main difference between S3 and Glacier is that Glacier is really designed for tape replacement. A good rule of thumb is if it was on tape before, Glacier is a good place for it. If not, you may want to reevaluate that. Integration with other ingest mechanisms. Ingest mechanisms in our minds are things like AWS Snowball and using AWS Direct Connect to guarantee that you have bandwidth. That guaranteed bandwidth is important when you have any kind of SLA that you're trying to meet. When it comes to talking with the cloud or putting data in or taking data out. In many cases, the internet's just fine, but the internet, as we all know, doesn't have QoS. In AWS, we have a shared responsibility model when it comes to security, and that shared responsibility model means that we're prepared to take care of everything effectively up to the VPC. So we take care of all the physical components. We have third-party audit certifications around who has access and in what capacity. We take care of all of our overlay networks. We take care of all of the routing topologies. We take care of all of the hardware availability, because after all, it is still real hardware. That part we haven't been able to get away from. And then from the VPC layer and on up, the customer is responsible for it, and that can be a fairly large scope. That's another great reason for using AWS Technology Partners, is it reduces the scope that the customer really has to worry about by effectively offloading large portions of the security model, the shared security model, to the partner solution. So, for example, in the case of StorReduce today, they have a great way of interacting with AWS services, following our security best practices, and they're able to ensure that the data is not only protected from a client-side perspective, but over the wire and then at rest when it lands in S3. Some of those certifications that I referred to are up on the screen right now. Again, all of these are certifications that have to do with things like endpoint compliance and the physical components. So if any of these compliance or icons or certifications are relevant to your organization, if you've ever asked the question, will I be able to retain them or attain them inside of the cloud, the answer is emphatically yes, you're eligible for those things. There's even more than these. This is a subsection of the certifications and assurance programs that we participate in. So when I say you're eligible for them, what I mean is we've done our part, and in any case where there's compliance or assurance that you're then responsible for in that shared responsibility model. All the parts that we have to do are taken care of for you, and you don't have to worry about them. We have third-party verification components that we can help with, and then you actually just have to do your end of it. So now I introduce to you Hugh Emberson, CTO of StorReduce. Hugh, take it away.
Thank you, Isaiah. Hi, everyone. I'm Hugh Emberson. I'm the Chief Technology Officer of StorReduce. My accent is not from the US, but StorReduce is actually a US corporation, and I'm resident in the US, and we have key teams across the US and elsewhere. So StorReduce is a scale-out, software-defined deduplication engine for object storage, like Amazon S3. StorReduce can do deduplication of data, can do deduplicated replication of data between regions and clouds, which is great for hybrid cloud, and it can do cloning, which is near instantaneous copying of entire cloud data sets as many times as you need. It works on backup workloads, but also on data that does not deduplicate, including big data and Internet of Things data. Today we're going to focus on the deduplication aspect of StorReduce and the new storage use cases that enables for your backups, as shown in the top two diagrams here. The first is moving your primary backups off purpose-built backup appliances like data domains and Veritas appliances, and instead storing that data to cloud, which saves you up to 80% on a total cost of ownership basis. Secondly, moving data off tape and storing to cloud, saving up to 60%. StorReduce enables you to deploy on commodity hardware in your existing backup solution on premises, and with a mere configuration change, you can point petabytes worth of backups away from backup appliances like data domain and Veritas appliances and tape to the cloud. I will walk through architectures, outline performance, and do a demo at the end of the webinar. I will also demo how you can use generic cloud services on the primary backup and archival data that you have moved to the cloud to access that data in near real time and derive better search and recovery, data mining, and more on it. The backup and archives of a company are typically the longest history and sometimes the largest pool of data that that company has. Now enterprises with hundreds of terabytes to hundreds of petabytes locked on tape or data domains can move data to the cloud. They can store it in a single pool on cloud and then be able to use best-of-breed cloud services to search, to train algorithms against historical trades or events, and to do AI or sentiment analysis across that data in real time or near real time. Not only does StorReduce give you a saving of up to 80% and much better durability and scalability for storing your data, it can now give you insights that provide you an enormous competitive advantage. And here's the workflow that we will demo later. So data comes in from purpose-built or off purpose-built backup appliances or tapes, or directly from your backup application into StorReduce, and it's stored into Amazon S3. We can then extract metadata from that data and put that data into search services or machine learning services, analytics services, for instance, and use those to derive intelligence from your data. For instance, you can search inside all of the backups that you've ever made for any word or phrase in those backups, which is very useful for people who have got very high compliance requirements, like banks. And it's much easier than just looking through a catalog of backups, which just gives you a list of the file names that you've backed up over time. So this is how StorReduce works. The StorReduce server is a single piece of software that can deploy on premises. It can deploy as a VMware virtual machine or as a Docker container on your bare metal hardware, or it can deploy as an AMI in Amazon EC2. The data comes in to StorReduce over the S3 interface. We have the same interface as Amazon S3, and that data is deduplicated at high speed in real time, and the deduplicated data, which is much, much smaller, is then stored into Amazon S3. So StorReduce reduces the cost of storing that data into the cloud and also the cost of transferring it into the cloud. The data that's stored in there includes all of the metadata that we use to deduplicate it. And this means that if the StorReduce server is ever lost for any reason, if there's a hardware failure or if the data center burns down, then you can recover the data that's stored simply by pointing a new StorReduce server at the bucket in Amazon S3 and recovering all of the data out of there. And we have optimizations that make that a very fast process. Now the data comes into StorReduce from anything that has an S3 API client. So most major backup software has an S3 client. Lots of file system gateways like QStar have S3. And anything else that has an S3 client, for instance like the Amazon S3 CLI, can be used to move data into StorReduce. The only hardware requirement that StorReduce has is that it requires a small amount of SSD. Well, it's less than 0.2% of the volume of data that's written through StorReduce. So if you have 1 petabyte stored through StorReduce, then it requires less than 2 terabytes of commodity SSD. A lot of other systems that deduplicate data and move it to the cloud will require at least 20% of the data that's stored to the cloud to be also staged or cached on local, highly redundant disk, like a SAN. And this can cost you tens of thousands of dollars per site. StorReduce removes all of these issues at petabyte scale. These are some of the characteristics of StorReduce. Firstly, it's fast. A single instance, that's a single server of StorReduce, can do 2.5 gigabytes per second of ingest. Multiple servers can be ganged together into a cluster to produce even higher throughputs. In fact, we can cluster to tens or hundreds of instances. StorReduce's deduplication is inline. It happens in memory in real time. We don't cache the data and deduplicate later. It's multi-threaded. You can handle hundreds or thousands of simultaneous streams of data coming into StorReduce. Our deduplication algorithm is a variable length block size algorithm and produces deduplication results as good as the best appliances. The StorReduce server, as I discussed before, is stateless, and this means that all the metadata and data is stored safely in the cloud. You can afford to lose the service if that happens. The StorReduce server is also scalable. You can cluster servers together, but you don't pay per instance of the server. You only pay for the amount of data that's stored through StorReduce. So it's great for multi-site deployments. And StorReduce has a single namespace, so there are no silos. You don't have to move your backups from one silo to another when that silo starts to fill up. As I've discussed before, it's completely software defined, and StorReduce is enterprise ready. It has high availability and region-to-region or cloud-to-cloud replication as well. And finally, going back to the Amazon shared security model, StorReduce is secure. All data that goes in and out of StorReduce goes over TLS or SSL, so it's encrypted in flight. And data can be encrypted before it's stored through to S3 using our client-side encryption. We support getting keys from Amazon KMS service or any hardware security module or key management system that supports the KMIPS protocol. And finally, we support the Amazon S3 SSE extension, which enables you to encrypt the data inside S3 just before it lands on the disks. This is the architecture of a StorReduce cluster. You can gang any odd number of StorReduce servers together to form a cluster. And this gives you a single namespace. It's highly available. It gives you a single dedupe pool across the entire cluster. You get 24/7 throughput because there's no buffering in the system. There's no buffers to fill up. And you can run 24/7, 365. And it's all built out of commodity hardware. There's nothing that's shared in here except for the network and the object store, or Amazon S3 in this case. Now this all relies on you having good bandwidth to the cloud. In order to get good throughputs, something like an Amazon Direct Connect is a really good way to go and get this bandwidth. And StorReduce gives you a deduplication speeds of tens or hundreds of gigabits per second through into Amazon S3, matching or exceeding the speeds of leading backup appliances. So this is a StorReduce cluster running in Amazon EC2. At the time that the screenshot was taken, it had 11.2 petabytes of data stored in the cluster, which was deduplicated down to about 570 terabytes. That's a dedupe ratio of 95%, or roughly 20:1. This was a 9-server cluster, 9 Amazon C3 8X larges, So it was a mid-sized cluster for us. And basically you can scale a cluster like this to increase your throughput just by adding more servers. And in fact, we will demo another cluster soon that has even more nodes and higher throughputs. If you add more servers to the cluster, then you get a linear increase in throughput. And this does not drop off as the amount of data stored increases. So for instance, a 35 node cluster could ingest about 100 petabytes per month. This cluster was ingesting about 750 terabytes a day. And StorReduce works with Amazon Snowball or Snowmobile, which are great ways to actually seed your first backups into AWS by taking the network out of the equation. So this is the major use case. Essentially what StorReduce enables you to do is to decommission your existing backup appliances or tape libraries and instead point the data that's coming out of your backup application to StorReduce and then into the Amazon cloud. This can give you a TCO, or total cost of ownership saving, of up to 80%. And there's a TCO calculator available from AWS or on the StorReduce website. And the StorReduce has the additional benefits that there's no single points of failure in the architecture. Because the StorReduce clusters are highly available, you can lose any 1 or 2 servers in the cluster and keep on going. You have no silos, so you don't have that problem of shuffling your data around as your appliances start to fill up. It's scalable. You can add more instances as you need more throughput or more capacity. And you can use cloud services on the migrated data, which is something I'll be demonstrating later. And the most compelling proposition here is removing backup appliances like data domains or Veritas appliances or Quantum DXIs as they come up for renewal, and then providing a more scalable, affordable, and durable storage for your data in the cloud. Now, StorReduce works with most major backup applications. StorReduce is a Veritas Technology Partner, and we work with Veritas NetBackup 7.7 and above. We're in the NetBackup 7.7 console. Veeam will soon have an S3 interface, and Commvault as well has an S3 interface that we can work with. Other backup systems which have a CIFS or an FS interface can be used via QStar, which provides an interface between CIFS NFS and S3 for StorReduce. And now we're just going to have a quick audience poll. And the question here is, what AWS services would you use on your backups that StorReduce has moved into the AWS cloud? Okay, and thank you everyone. I'd now like to thank our client, Globe Telecom, for doing this webinar today, and especially thank Danilo Cardona, a great infrastructure architect with Globe Telecom, who helped implement this architecture at Globe. Thank you, Danilo.
Hi guys, I'm Danilo Cardona, an infrastructure architect of Globe Telecom. I will be discussing today how we archive our primary backup data from data domain to AWS Cloud. Let me just give you a brief background about Globe Telecom. Globe Telecom is the largest telecommunication company in the Philippines with over 65 million subscribers. We have different types of applications deployed in AWS and also in our own private cloud, and some are still deployed in on-premise physical servers. We do have a backup solution where we back up our on-premise service data to EMC data domain. A problem arises when we are already running out of capacity due to growth in and retention of backup of data. So we are now looking for another solution where we can help us in addressing our problem. The goal of our solution is to repurpose our current on-premise appliances. Also, we need to be able to archive all backups from data domain to AWS rather than repurchasing additional storage in our backup appliances, as they are expensive. And we also want to leverage the cost savings that we will going to get if we're going to use cloud storage. And aside from this, we also want to all of this happen through automation. There are some challenges that we encountered in making the solution, like some of our systems, mostly billing systems, has data that has up to 10 years data retention. And we found out that archiving this long retention data is too expensive without the duplication. In terms of our network and security requirements, our solution must utilize our own AWS Direct Connect line to AWS, and the encryption over this wire should be encrypted, as well encryption at rest. We also want a solution that scales with data growth, and we didn't want to change our existing workflow. We have a self scripted backup solution, and we want this solution can integrate with our current solution. We'll be able us to store our data to cloud. After studying and searching up different solution and software, we found a very interesting software that promised of having an inline deduplication to AWS object storage, and that is StorReduce. We found it in one of the posts in AWS APN blog, and the best thing about it is that it's available in AWS Marketplace, so we can do self-service procurement and try the software as soon as we want. Aside from having able to back up our data to AWS, it also works with our own existing hardware, so there's no new investment requirement. Also, it is scalable and achieves an excellent deduplication ratio that increases backup window times, bandwidth, and storage costs. And we also able to integrate StorReduce into our existing backup script using the AWS CLI to enable backup retention in data domain and also in AWS S3. So this is our previous design. We do have systems that backing up their data in our data domain, and we do have we created our own backup script to automate this. We validate the solution by performing a proof of concept, and this is a solution that we have. As you can see, we installed StorReduce in one of our VM and have StorReduce help us in creating the script for automating the process of archiving to S3 and data retention. We also use our existing proxy farm to be able to leverage our own direct connect line to AWS S3. And we use S3 infrequent access for storage. We are deployed our servers in Singapore region of AWS, and currently Glacier is not yet available, but sooner if Glacier will be available, that will be another savings. The POC was quick and effortless. We were able to upload and download 3 months worth of backups of one of our systems with just a week. After that, we were able to move straight to the production from POC without having to re-upload all of this data. And we have successfully launched it to production last June 30, 2016. These are the results, as you can see on the screen, of our POC. So we were able to upload 250 gig backup file in less than 5 hours and 20 minutes. We had an initial duplication of 70%. And we just only utilized the bandwidth of our direct connect for only 10 megabits per second. And we also tried to rehydrate the data back to our data domain. And with the 250 gig of backup, we were able to recover it for only 6 hours and 40 minutes. So overall, the successful backup and recovery rate of our POC is 100%. So this is the current duplication statistic that we have right now in our production. This is the as of August 2017. So we have already uploaded 94 terabytes, and with 88.8% deduplication, we just only able to store. We have able to have deduplicated it to 10.54 TB bytes. So that's it. We are able to archive most of our data with StorReduce in AWS S3, which we trust as a very secure joint solution. The shared responsibility security model was ideal for our requirements. The infrastructure combination of AWS cloud storage and services with APN partner like StorReduce delivered the total solution that we required. So that is for our session. I hope that you learned something from this, and I'll be now turning over you to Hugh Emerson for the live demo.
Hello everyone, it's Hugh Emerson here again. Yeah, thank you Dandelo for presenting and discussing your experiences with StorReduce and AWS Cloud. So this is the StorReduce dashboard. This is a cluster running in Amazon EC2 on about 15 servers. And what StorReduce shows you here is firstly how much data is stored within the system. So we have currently just over 4 petabytes of data stored before deduplication, and roughly 130 terabytes after. You can also see the network activity. This is data coming into the StorReduce server. We're averaging somewhere around 12 to 13 gigabytes a second of data coming in, which is roughly a petabyte a day. Just clicking to the next tab. This is the StorReduce Explorer. Basically, it's like the Amazon S3 console, if you're familiar with that. And here are the buckets that are stored within StorReduce. From here, we can basically click into a bucket and see the data that's stored in there. This bucket contains the test data generated by one of our test scripts. We can do other things like, create a new bucket. I've already used Fred, James, and pop data, have a look in there. We can upload files into the bucket. Again, just like the Amazon S3 console. And there you can see the data has been uploaded into StorReduce. And we can also download the data from StorReduce and check that it worked. Of course, most of the data that comes in StorReduce doesn't come in through the dashboard. It comes in through the S3 API and from other machines. Now, StorReduce is very easy to set up, even if you're setting up a cluster. Essentially, all you have to do is fill out this form, which just contains things like the Amazon region that you're connecting to and the bucket in S3 that you're going to use. A few other things about encryption, security, and so forth, and then all you have to do is push the Save Settings button. Now, even if you're setting up a cluster, all you have to do is configure one server. You then join all the other servers in the cluster to this one server. And StorReduce is a masterless system. That means that every server in the cluster is both a master and a slave. There's no master that you have to worry about protecting. They're all equivalent. And you can see this dashboard from any one of the servers in the cluster. This is the cluster management screen. It shows you the servers in the cluster. You can see their IP addresses, version of StorReduce that they're running, when they were last restarted, and so forth. And you can see that the portions of the namespace that each of the servers is responsible for. What we can see here is that this server is set up as a single replica, or this cluster is set up as a single replica cluster. Each server is a replica of one of the other servers in the cluster. And this means that the cluster can withstand the loss of any one server in the cluster, and it will keep on going. We can also configure StorReduce servers so that they can withstand, or clusters, so that they can withstand the loss of 2 or more servers within the cluster and continue to function. StorReduce has a identity and access management system, a little bit like Amazon, and this allows you to assign IDs, create users within the system, and also then assign permissions to buckets to say which users can access those buckets, or I should say policies. And we use the Amazon policy language. So if you're familiar with that and using IAM, then you're familiar with using StorReduce and its access control as well. Now that's all I've got for this. One final thing actually. If StorReduce ever has any problems, if it starts running out of disk space, for instance, on the server or something like that, it will display notifications up here. You can also configure it so that it can send you an email if it starts running into problems. Now that's all I've got to show for this cluster, but I've got another system to show you here. And this is a product that will be going general availability sometime next month. It's called StorReduce Insights. And StorReduce Insights is the system that allows us to derive business value and insights from data that's been uploaded via StorReduce into the Amazon cloud. Now, what I have here is a Windows server. In here, I've got a data set with a bunch of documents in it. These documents were all scraped off the internet. There's about 1,000 documents in the data set. And I've used NetBackup here. This is Veritas NetBackup 8 to back up that data set a couple of times into StorReduce. Here is the StorReduce server that we backed them up into. And here you can see, if you're familiar with NetBackup, you can see familiar looking NetBackup policy names and file system structures. Now, the data that's gone into this system is being inspected by a StorReduce Insights server, and the Insights server is pulling out that data and the metadata associated with it. The metadata gets injected into a Elasticsearch cluster, and the Elasticsearch cluster then allows us to do queries over that data. So, for instance, here is we're using Kibana to just inspect the results of the Elasticsearch cluster, and we can see that we're looking at the archived files table within Kibana, within Elasticsearch, and we can see that we've got about 2008 files in the table. These are files that have been backed up from the Windows server that we saw before. And we can see the metadata that we've been able to extract from the data that was backed up. We've got, the backup run, the backup ID, the file name that was backed up, and so forth. And there's a lot more information here. We've got access times, the change times, the group, and the user who created this file, and much, much more information. But the neat thing that we can do with this is that we can search it. For instance, we can run a search for contract. Now, this will go and find all the files in the system that either have the word contract in their file name, like these ones here, or we can find files that have the word contract inside the file. We've got a link to the file, so we can actually go and download that file, or we can do other things like we can export that link to another system which can then analyze the contents of that file. We can also use Kibana or any other system that understands Elasticsearch to do analysis on the system. So we can look at, for instance, what dates the file modifications were made on, or what years. We can see, for instance, who are the most frequent users or most frequent file modifiers within the system. But any piece of metadata that you can pull out of the system can be fed into this and can be used to derive insights about your data. And because everything is exposed via an API, in this case we have the Elasticsearch API and just HTTP for getting the files, you can feed that data into any other application that can understand those and derive insights from it. For instance, you can use data mining applications, analysis applications, machine learning applications. And this is only because StorReduce stores your data in a single namespace on cloud with open APIs. And it has scale out with very high throughputs that enable you to pull back your data in near real time. And that's the demo. We're finished here. I think it's time to hand over to Isaiah for Q questions and answers.
Awesome. This is so cool, actually. I work closely with you guys for the last couple of years, and we've always talked about what insights you could derive from that kind of information. And so seeing it live, this is the first time I'm actually seeing this. This is so cool. This is really neat. I'm thinking about our customers who need basically like all the features that you would get in like an enterprise vault type scenario, but without having the high cost. And without having sort of a vendor lock-in, right? I mean, ELK and the whole Elasticsearch and Kibana component is just it's pretty well accepted amongst the internet world as it's open source, and you'll be able to benefit from things as that project moves forward. There's a couple of questions that people have had that I think are really pertinent around how to get the best value out of StorReduce. Tim asked, in what order and combination should you employ deduplication, compression, and encryption? So it's a good question. And a lot of times people maybe they thwart their own attempts to optimize things. Can you provide any best practices for what they should do or not do to data before putting it into StorReduce?
Yes. So encryption and compression tend to kill deduplication. So what we do is we take the data in uncompressed and unencrypted, preferably, and then we actually do after deduplication. StorReduce actually does compression and encryption. So that's the optimal order to do it in, and it gives you the best results.
Got it. Okay. Doug had a great question about incorporating Glacier. His question specifically was, does StorReduce support direct writes to Glacier? But I'd like to just take a step back and understand, if I'm a StorReduce customer, how can I take advantage of Glacier?
Yeah, so StorReduce does not support direct writes to Glacier, but we can move data in and out of Glacier via lifecycle policies.
I was just going to say that the list of people who support direct writes to Glacier is actually incredibly small. Of something like 70 odd storage partners, I think there might be one partner that supports direct writes to Glacier. I know the API is different, and there's at least one feature such as Glacier Vault Lock that you can take advantage of by using direct writes to Glacier. But in your experience with the dedupe ratios that you get from customers, is it really necessary? Does it, from a cost perspective, is it prohibitive to do lifecycle policy migrations? What's been your experience with customers? What have they told you?
Most of our customers, after looking at Glacier, have decided against it, just for the simple reason that it has another layer of complexity to the situation. That said, that at very, very large scale, when you're talking hundreds of petabytes of tape archives that have been migrated, Glacier does actually start to look like a very attractive solution. Of course, the downside of using Glacier is that it takes a long time to pull data out of Glacier, and that's by design, but it means that you can't use cloud services against that data. So you can't do stuff like StorReduce Insights against the data that's stored. You could perhaps look at some of the metadata, but not the data that's there. Therefore, we recommend that people target the S3 IA layer, and they get very good cost savings because S3 IA is inexpensive, and also because they have deduplication. And
that makes a lot of sense, because I know that when even the Glacier cost model and even the S3AA model are a little bit complicated. When you put it into Excel or something and you start putting in the numbers, S3IA is pretty well down the middle of S3 and Glacier. And when you combine that with the great dedupe ratio, the value is definitely there. Tim had a follow-up question. Tim was the person who asked about deduplication, compression, and encryption around using StorReduce with on-prem object stores. I think it's a great time to remind our audience that you can use StorReduce with on-prem object stores. So his question specifically was, if you run it with Cloudian cluster and then tier the data from Cloudian to S3 or Glacier, will this work? And I think when he asked the question, will this work, he's referring to, will I be able to do restores, or, will I still get my deduplication results? Could you comment on that?
Yeah, absolutely. So we've got a really great hybrid story. We can work with most of the major on-prem object stores, Cloudian being one of them, and data can be, for instance, tiered first into an on-prem object store and then asynchronously replicated up into Amazon S3 for longer term archives. So that gives you, the benefit of having an on-prem object store for very fast recovery, especially if you don't have a great network connection, and then the long-term cost advantage of having Amazon S3 for your long-term storage, or S3IA. And yeah, in addition
Great.
to supporting deduplicated replication, so the data is deduplicated before it leaves your premises and always remains deduplicated. You also, and so which gives you a bandwidth saving as you're moving the data into S3, and of course the cost saving as you're storing it in S3. In addition to that, you can also run a StorReduce cluster in S3, and you can point it to the same bucket. So you can actually pull out your data in Amazon, and you can use your data up in Amazon as well as being able to recover it very quickly on premises.
Okay.
Sorry.
Basavaraja had asked a question about licensing, or with capacity-based licensing. Is it reflective of the front-end data that's being protected, or is it reflective of the back-end data that's the DB value?
So it's reflected of the front end, the before dedupe limit. But we've designed our licensing model so that you will always save money, and you'll usually save around 80% over on other on-premise deduplicating appliances, and around 40 to 60% over tape.
Excellent. Okay. Question for Dandello. The question, Dandello, is when you were implementing this, did you have any bumps or hiccups along the way that you could share with customers that maybe you already figured out the answer to? A lot of times when people go down the path of implementing something new, there aren't any real blockers, but sometimes there's speed bumps, if you know what I mean, things that would slow you down. If you could have a conversation with yourself in the past, is there any advice that you would give yourself?
One of the problems that we encountered is to integrate the script to leverage our AWS Direct Connect, but StorReduce were able to help us by setting the proxy in our script. So far, we didn't really aside from that, we didn't encountered any problems with the implementation.
So just integrating the scripts. Got it. And when you say integrating the scripts with Direct Connect, you mean just the changing the targets from something like S3 to the StorReduce endpoints. What were some of the things that you had to end up changing in your workflow?
Yeah, we just configured the proxy settings of the StorReduce to point to the endpoint of our proxy farm, so that it will going to utilize our data connect.
Right, because you wanted to be able to you want that reverse proxy farm so that you could scale up your ingest component. I gotcha. Okay.
I know.
Awesome. Thank you, Dandello. Question for Hugh. We have Paul, who's one of our attendees, asked about GDPR. And for those people who don't know what GDPR is, it stands for General Data Protection Regulation. It's an EU regulation where addressing the export of personal data, and specifically it's about giving control back to people so that they can purge data after the fact. Seeing this, the insights, the Kibana interface, and being able to search for things, I think that there might be something here for you to talk about. Paul specifically was wondering, if you're if you're hosting personalized data, and if a customer or a user wants to remove specific data, what would your approach be for finding that data related to the client so that it can be purged? It seems like that you might need to know what your schema is so that you have metadata that's canonical for each user. Can you talk about how the metadata gets discovered? Is there ways to add custom metadata? It's a little bit outside the scope of what we've talked about, but I think it's close enough that it's worth addressing.
That's a very interesting question, Isaiah. Yes, I think there's a way to do this with Insights. So Insights, when it's looking at your data, with the data that's passed through it, it can inject that data into an Elasticsearch cluster. And Elasticsearch has the ability to run filters across data that's injected into it. And so you can design it so that it can understand custom schemas. Therefore, you could, for instance, have a filter that understands your custom database schema or whatever your file format is, that then pulls out, for instance, things like sensitive names or something like that, and gives you the ability to actually find all of the data that mentions a person or organization. And then you can go through your backups, basically, and purge the data out of your backups, delete the data out of StorReduce, and I think you've accomplished the task.
Interesting. That's fantastic, because there really aren't very many solutions, just because it's a fairly new regulation. Well, actually, it's not specifically new, but the deadline for being compliant is coming up or has recently passed.
Right.
This is the kind of thing that cloud backups often don't necessarily address, which is how do you actually get rid of the data when you want to. Lifecycle policies are great if the data is sort of in its native format in S3, but when you're changing that format because you want to take advantage of deduplication, then you're reliant on the technology partners to actually leverage that for you. All right, well, that's all the time that we have. I really want to thank our attendees and our speakers. Dandelo, thank you so much. I know you're in the Philippines, so it's quite late there right now. I guess it's coming up on midnight. And I'm actually in Sydney right now, so it's 2 a.m. Hugh, and thank you very much for all of the insight and for showing us what's coming. That insights looks really, really cool. And thank you for attending.
Great. Thank you, Isaiah.
Thank you, guys.